All right, guys, let us begin the lecture. So a large number of people have joined. Okay, so first of all, can you guys hear me? Yes, and is this iPad screen visible? Perfect. All right, so guys, before we begin, we have a lot of questions up front. So let us quickly take them. All right, cool. So I see questions like this. So I see a question by Akshay. Akshay is asking, are we going to implement the code as well or just snippets? So Akshay, we are going to implement the code, but we are going to do that tomorrow. Okay, so this entire masterclass is in 2 days. So today we are going to cover some theory. We are going to break the problem down. Tomorrow we are actually going to go hands-on and implement that. Okay, perfect. Someone is asking, how many hours will the session be? Okay, so the timings for today's class is 2 p.m. 2 p.m. to 6 p.m. Right, and we will have a break in the middle. Okay, is it continuation of today's session? So we are beginning the session today. Okay, so this is just the beginning of the session. All right, Suruchi. Recording available. So Amal, the recording will not be available. The notes and the code, both these things will be available to you after the masterclass is done, but the recording will not be available. Okay, which language would this be in? So we will be following Java and Spring. Okay, now most of the content on first day that we will cover, we will try to keep it language agnostic. Right? So we will be explaining the code in Java. However, if you want to understand how this will relate or transfer to some other language, feel free to ask me. Okay. How long is the break? The break will be around 30 minutes. Okay. All right, that seems to be most of the questions. Let us quickly see what other questions we have. Okay. All right, so let us begin with the class then. So, hello, I'm your instructor. My name is Pragya Dalwal. Okay, and I am a senior software developer over here at Scalar Academy. Before Scalar Academy, I was working at media.net. So you might have heard of this company. It is a direct hire company. Right. Now, I personally have had 16 years of coding experience. Not all of that is professional, but I learned coding way back in class 5th. Right. And since then, I have been coding. Coding has been a large part of my life. And you can visit my LinkedIn profile to get more details about it. Okay. Now, let us come to the core of this thing. What are we going to cover today? We are going to cover low-level design. And why should we cover this? Okay, why on earth are we covering low-level design? So there are multiple reasons. So first of all, any good tech company, right? If you look at Google or Amazon or Uber itself, right? Or any good tech company, if you look at their interview processes, they especially have a low-level design round. Right, round. Now, it might not be with the name of low-level design, right? It might be with the name of machine coding, or it might be with the name of object-oriented programming. Okay, but all these companies, they definitely have a low-level design now, especially for roles like SD2 and SD3, right? So for any role above SD1, 2, 3, they definitely have these LLD rounds. In fact, some companies have these LLD rounds even for SD1. So Google has it, Uber has it. I'm not really sure about Amazon, right? But at least these companies, they have low-level design round even for SD1 positions. Okay, cool. But I mean, interviews is one of the things, right? Interviews is one of the things. The entire thing is not interviews. Let us quickly look at the interview perspective. So a lot of people focus on the high-level design part. Right, so you will find thousands of videos on YouTube. You will find hundreds of blog posts that will talk about the high-level design, the architecture design of Uber. Right. However, once you have created the architecture design of Uber, how do you actually go ahead and write the backend APIs? How do you actually code it out? That is something that most of the people they skip. Right? But this is very important, and we need to learn that. All right. So we need to focus on not just the HLD, but also on the low-level design, right? Now, low-level design, just like high-level design, there's a lot of good resources online, right? So there's blogs, there's YouTube posts, there's courses online. However, unfortunately, these topics are not really covered in the college curriculums, right? And the reason for basically for that reason, the content of low-level design right? There's very high quality content available on the internet, but it is kind of segregated, right? It's distributed across various locations. So there's no one place that you can go and learn low level design, unfortunately. Right, so we are trying to bridge this gap over here. So we offer an entire course that will teach you high level design, low level design, project building, and things like that. Okay, cool. So let us begin with what low level design is. So low level design basically talks about these three things. If you have to write code, right, as you grow in your software career, you will be writing a lot of code, right? Now, as an SDE1, as a junior developer, what kind of code will you be writing? So there will be someone, there will be a team leader. There will be a team leader in your team, and that team leader will hand you some requirements. So the requirements can be that, okay, I need you to develop such and such API, right? Or perhaps we have this payment gateway, something like Razorpay, and let us integrate this Razorpay on our system, right? So you will get requirements like this, and what you will have to do is you will have to code them out. Now, along with the requirements, most likely the team lead will also give you a structure that, okay, please make this class, please expose this API endpoint. These are the REST APIs that you have to create and things like that. This is the database schema. Please follow this database schema, right? That is the job of a junior developer. But as you go senior, as you become, as you advance in your programming career, this is not enough, right? This is not enough. You are not always given the requirements yourself, right? So usually you have a vague idea. You have a vague requirement, something like, okay, I want to design Uber. And you have to think about that problem. You have to think really hard. You have to break that problem into small parts, and you have to execute each of those parts, right? Now, while you are doing this, it is very important that the way you write your code or the way you structure your code is extensible, maintainable, and testable. Okay. So quickly, I mean, these are just three words, right? So what is the meaning of extensible? Can someone tell me that? What does extensible mean? Extensible, does it mean scalable? Not really. Exactly. So a lot of you have the right idea. So extensible means that it should be easy to add or remove features, right? So most of the time when you're working with personal projects, you already know that, okay, I am going to build this. So suppose that you are building a note-taking application. You will already know that, okay, I will have some users. They will register on my website. They will be able to take notes. The notes can be tagged. I can search through the notes and so on and so forth, right? So this is, your requirements are fixed and they are not going to change much. Perhaps you will be adding a few features down the line, but the core of the application will remain the same. However, when you look about large scale systems, things are really, really messy. So when you start a company or when you start a product, when you launch a product in a company, you have some vague idea of what your clients might require. Right? So you create a product around that. After some time, a lot of things can happen. So new clients can be added. So new customers can be onboarded, right? Some special features have to be offered, right? New features need to be created. What else happens? So it could be the case that you realize that, all right, I was offering this product. This product is not really bringing me any revenue. So I need to close this, or perhaps I need to launch a new product, right? That happens. The requirements of the API changes. So currently your clients were, let us say, just looking for some particular data. Now, tomorrow a new client can come and they could tell you that, okay, I want, apart from what you're supplying, I also want this data, right? So you need to add some things to your pipeline. So all of these things happen and they happen very frequently, right? It could be the case that you are currently using MySQL as a database, right? And your company is moving to a PostgreSQL database. So you need to make sure that the migration happens smoothly, okay? Now, once again, it is not the case that you are going to tackle these things when the requirement arrives, right? It is not the case that you're going to say that, let me build this product. Now, when some changes are required, when some changes are right, only then I'm going to think about those changes. That is not going to happen. Because if you do that, then you will spend a lot of the time making these changes, right? So you write your code. If a new change comes, if you have to change like 60 to 80% of your existing code, that is very bad, right? So you have to anticipate and think of these changes beforehand. You have to anticipate and think of these changes beforehand, so that whenever a new change comes, you can incorporate that change by changing as little code as possible. Right? You add on code, you do not have to change the existing code. Does that make sense? That is what extensibility means. Yes? Okay. What about maintainability? What does maintainability mean? Easy to debug and optimize, all right? Easy to fix issues, readable. Mm-hmm. So yes, maintainability means that your software should be configurable. Configurable, right? It should be easy to debug and it should be easy to upgrade. Yes. Apart from that, it should be easy to do knowledge transfer. Knowledge transfer. DGE transfer. Right. So let us take each of these things one by one. Just give me a second. My application is trying to update itself. Okay. So you guys can hear me once again, right? Yes. Okay. So what do we mean by configurable? So usually what will happen is you will have some piece of software and you will write the software in a generic manner. That software will allow for multiple configurations. Right? Now you have to write your software in a way such that if the configuration changes, right, you don't have to change the code, recompile the code, retest the code, and redeploy the code. Okay, that is a big no-no. So basically, let us say that you have some piece of code, over here, and you have deployed it to the server. You have deployed it to production. Right? Now, suppose that someone says that okay, instead of there was some constant in your code. This constant had the value 10. Someone says that okay, instead of 10, I want to make it 15 for some particular reason. Now, if you have to change your code, recompile it, redeploy it, test it, that is going to take a lot of time, right? That is very, very difficult. That is going to cause your service to go down for a long time, and a lot of things will happen, right? A lot of issues will happen. So you need to make sure that any configuration changes in your code, changes in your code can be done without redeploying the code. Does that make sense? Yes. What about debugging? Well, the code has to be written in a manner such that it is easy to understand and it is easy to debug. Right? For example, deep nested if-else statements or large function bodies. These are bad ideas, right? Because they make the code really, really complex. Does that make sense? Charan is asking, is this where the 12-factor app standards help? So yes, sir. 12-factor app standards, they talk a lot more than configurability and testability. So 12-factor app standards, they're very extensive. And I mean, usually you should strive for achieving them. Right? Perfect. What about upgradability? So this depends on software to software. Suppose that you are launching something like Uber, right? Now Uber has a backend API, but it also has a client-side application. Right? You also have an Android or an iOS application. Now you want to make sure that whenever your backend API changes, you can still push changes to the Android application independently. Right? It should not be the case. That for every backend API change, you have to launch a new version of your app. Right? This should not be the case. Because if that is the case, then your backend team, it is dependent, it is blocked by the front end team. Right? Your backend API should be able to evolve on its own. And only for major backend changes you have to redeploy the new front end version. Similarly, you don't really have to worry about the backend API when you are developing the UI of the application. Right? So the backend and the front end must be decoupled. Does that make sense? Also, so suppose that you have the backend API version 1.0, right? So this backend API version 1.0 was using your app version 1.0, right? Was being used in your app version 1.0. Now you had released a backend API version 2.0, and you had also released the app version 2.0. Now, not all of your users will start using app 2.0 immediately, right? There will be a delay. Some of the users will not have updated their applications. Does that make sense? Now, if they start their application, of course, you might prompt them that, hey, a new update is out, please update your application. But some basic services should still be available, even if someone is using this old application and this old API. Does that make sense? So just because you are launching a new API, you cannot just say that, okay, my old API is completely useless. You cannot completely remove the old API. So that is what we mean by maintainability. Okay, that is what we mean by maintainability. Well, what about testability? What about testability? What does that mean? So yes, Shoprana has the right idea over here. It means that it should be every piece of every individual piece of our code, right? So individual components, visual components should be testable separately. Should be testable, right? Basically in isolated manner. Isolated manner. So basically, let us suppose that you are creating an Uber feature. You want to, so currently let us say that you are trying to launch a Uber self-driving car feature. Self-driving car feature. Right? For the self-driving car feature, you will have to have a lot of things, right? You will have to get you will have to get permissions from the government. You will have to make sure that it works on all sorts of roads. It works on highways. It works under various weather conditions, right? Now, suppose that you are developing the backend API for that. Just because you are developing the backend API for the Uber self-driving car, does it make sense that you need to have a self-driving car ready? That does not make sense, right? Similarly, when you're testing the backend API of a self-driving car, or suppose that you are testing how a self-driving car will be routed through the roads, right? Do you need to have everything, the entire system in place? No. Having that will make testing very difficult because you will have to test everything together, and it will make finding the bugs much more difficult, right? So we should be able to test each and every piece of our software individually. Does that make sense? Now a lot of concepts come over here. And we will talk about how basically low-level design helps us in achieving these three things. Okay, so these are a lot of requirements, but how on earth do we achieve these? All right. So these are the basic principles of how low-level design helps us achieve these things. Okay. So first of all, let us talk about object-oriented design. So I hope that all of you are familiar, at least on some level, with object-oriented design. Yes. All right. What is object-oriented design? Well, this is a design pattern. I mean, this is a programming pattern. Now, object-oriented programming is useful in a lot of cases, but it is not the only design pattern, right? So, for example, if you look at game developers, right? If you look at companies like Valve, right, who develop large-scale games, very real-time games, then those people usually code in C++, and they really hate object-oriented programming, right? They swear by something called a data-oriented programming, right? Pattern. Right. However, when you're designing large-scale systems, unless you're designing very, very heavy code that needs to run extremely fast, something like high-frequency trading or something like games, other than that, object-oriented design is one of the best things, one of the best ideas that you can employ in your code. Does that make sense? Yes. So what does object-oriented programming really talk about? It tries to model the world. It tries to model the world in terms of concepts and objects. Right? So we will discuss more about this, but object-oriented programming tries to break the world down into concepts and objects and abstractions. Right? And it allows us to think of our code in terms of these objects, and thinking in terms of these objects comes naturally to humans. Right? Since the rest of the interaction with the rest of the world is in terms of objects and entities and basically relationships. So thinking in object-oriented terms makes software much more easily understandable for us. Okay, perfect. Abstraction. What does abstraction mean? What does abstraction mean? Basically, when you're trying to solve a problem, right? When you're trying to solve a problem, it is not a good idea to solve that specific problem. Right? That specific problem. You should always try to solve a general problem. General problem. Right? So basically, what abstraction allows us to do is it allows us to take away the details. Right? It allows us to hide the details of a problem and only focus on the crux of the problem. Does that make sense? Once we have the solution for a crux of a problem, then we can make changes to it to add on the details. Does that make sense? For example, let us suppose that we have this wire. Right? Let us suppose that we have this wire. It is made of copper and it has some radius. Right? Let us say it has some radius. Now, one of the abstractions that we have created in physics is the abstraction of voltage, current, and resistance. Yes? This is one of the abstractions that we have come across. Yes, and what formula do we use to relate these things, these three quantities? We use V equals to IR. Right? Voltage, the voltage drop equals to the current times the resistance. So this is the voltage drop. Right? Now, is this really happening? Is this really happening at the molecular level? No, at the molecular level, what you have is you have a nucleus and there's an electron cloud around it. Right? It is not proper orbitals, it's just an electron cloud. Now, what happens is these atoms are arranged in some sort of a lattice structure, right? There are some impurities over there. Then there's a voltage applied. So a voltage has been applied. And what happens? So some electron gets knocked out from here, right? Some valence electron gets knocked out. It free flows inside the lattice, right? So there's a hole created over here. Because of the voltage, this hole propagates. And so basically the electrons are moving from the right to left direction. And we say that, okay, the current is moving from the left to right direction. Oh, this is the opposite way by that. Okay, so this is plus and this is minus. Right. Now, if we are trying to think, if we are trying to model some electronic system, right? You're trying to fix your fan, right? And you have to think in terms of these molecules and these lattices and these electrons. You will never reach anywhere, right? You will never reach anywhere. So basically, for example, if you want to Google something, right? If you want to search something at Google, if you have to think about the individual bits that are being sent, how the voltages are being manipulated in the wire, right? How the data is being transferred under the ocean, right? Then you're not going to be able to do anything. So it is always better for us to look at the high level problem so that we can hide the internal details. We always try to work with abstractions. Does that make sense? So low-level design talks about how to generate good abstractions. What are design patterns? What are design patterns? Well, as you grow and as you code, you will identify some common templates, or some snippets, right? That can be applied to a lot of programming problems, right? A standard solution to a particular problem, right? For example, let us say that you want to make sure that you have a class and this class can only have a single object, right? Single object that is shared across everyone. Now, this is a pattern. There's a specific pattern to handle these kind of cases, and that is known as the singleton pattern. In fact, object-oriented design in itself is a programming pattern, right? It is a programming paradigm, but it is also a programming pattern. Does that make sense? So over the course of history, we have been computing for a long time, right? So back from the 1940s, we have been computing. So it has been like 80 years since computer science has been invented. Now, in all those 18 years, we have improved our computer science tools a lot. So back in the day, people used to program using punch cards. Yes, are you aware of that? People literally used to make grooves inside a card and use that to program. Now we have come a long way from that, and the way we have arrived here is by identifying that, okay, this problem, if I want to solve this problem, then this is the approach that I can apply. So design patterns gives us a collection of these approach of these templates. It gives us a framework for solving problems, common problems. Okay. Apart from that, low-level design talks about figuring out and using the proper technologies. So what do we mean by using the proper technologies? So first of all, you have to have a mastery over your programming language. Right? What programming language is appropriate for this particular task? So if I'm trying to create some really complicated system, something like Uber, should I be trying to program it in Fortran? Should I be trying to program it in COBOL? Should I be trying to code it out in assembly language? Does not really make sense, right? Similarly, if I'm trying to create something that does a lot of fast numerical computations, right? Let us say that I'm trying to create a deep learning library and I'm trying to optimize the matrix multiplication procedure in that. Should I be trying to code in something like Python? I perhaps should not, right? I should use a very low level language. So you have to choose the right technology over here. Programming language is one technology. What other technologies are there? So when you have a program, when you have a large scale system, you always interact with some sort of a storage or some sort of a database. Right? Now databases come in variety of sizes and variety of shapes, right? So you can have a SQL database, you can have NoSQL databases, you can have columnar databases, you can have in-memory databases, right? A lot of things are there. So for your problem, you have to figure out what is the correct database to use. It might be the case that your problem has several parts. For this part, you have to use this database, and for some other part, you have to use another database. You have to be able to identify all of them and apply that. Does that make sense? Yes. Apart from that, we have choosing the right algos, right? Choosing the right algorithms. So a lot of the times, what people do is they just try to solve the problem. They don't really care about, or is the solution efficient or not. Now, when we are dealing with large scale systems, as the system grows, as the scale grows, if we have a poor algorithm, then our system will become extremely slow, right? The read queries will become slow. Perhaps the time for competition has become slow. So we always have to focus on algorithms. Now, all of you are familiar with algorithms, right? In computer science, even in college, in competitive programming, in the interviews, you have all dealt with this algorithm task. Now, people kind of forget during low-level design questions, they kind of forget that algorithm is still a part of this, right? Even if you're designing a system, you also have to think of the algorithms. Okay, perfect. And finally, we talk about testing, right? So low-level design incorporates a lot of testing. Now, this comes in various flavors. So there are several methods that you can apply over here. So you can have mock tests, right? You can have unit tests. You can make sure that you have some sort of dependency injection, right? This helps make your test a lot better. You can have a framework for A/B testing, right? You can have inversion of control, and so on and so forth. Does that make sense? Yes. Okay. Cool. So let us quickly see and let us quickly wait and see what questions we have. So we have a lot of chat going on. Vinay is saying that the audio is breaking. Is the audio breaking for you guys as well? No, audio is good. Okay, so Vinay, that might be a problem on your end. All right, so we had a question somewhere in the middle. Akshat is asking, will this session be recorded? So once again, Akshat, the recording of this session will not be shared. The notes and the code, that will be shared. Okay. Perfect. All right. Now let us move on. Now, what will we actually cover? Right? What will we actually cover in this masterclass? Right now, let us try to not say what we are going to cover in this masterclass. Let us first try to identify what we should cover. Right? What we should cover. So basically, we have a Scalar Academy in which we have a log program, right? In which we teach students algorithms, data structures, low-level design, high-level design, and things like that. Now, one part of that curriculum is high-level design. We spend around 1 month on it. Okay. And in high-level design, what all things do you need to be talking about? In high-level design, can someone quickly give me a list of ideas, list of topics that you need to understand? You need to understand things like consistent hashing. Yes. You need to understand things like load balancing, right? The cap theorem, sharding, right? In the cap theorem, you have to understand the meaning of all these three things, right? So what is consistency? What is availability? What is partition tolerance? You have to understand how to cache things, caching and CDNs. Right? You have to understand how to do vertical versus horizontal scalability. Right? You have to understand how message queue works. Does that make sense? Yes. So there's a lot of things over here. That you need to understand. So once you understand these things, these are just the terms, right? These are just the terms. Apart from that, you also need to learn how to apply these. So you need to take a lot of scenarios and you need to see how to basically break down a particular problem, how to break down a design problem into these individual things so that you can apply all the concepts you know, right? Okay. In low level design, what do we need to cover? So apart from that, we have HLD for 1 month. Apart from that, we have LLD for 1 month, right? In LLD, you need to learn a lot of things. So you need to learn things like object-oriented programming. You need to learn this in depth, right? What is encapsulation? What is abstraction? How does inheritance work? What is composition? Why is composition better than inheritance? A lot of things over here, right? You need to understand the design patterns. Now, there's a lot of design patterns, right? I mean, you can have thousands and thousands of design patterns, but there are a few patterns that are used across the industry. So no matter what company you go at, you will almost always find this sort of a design pattern. So can someone tell me some very frequently used design patterns? So factory pattern is one. Yes. Builder is one. Singleton. Yes. What other things do we use frequently? Adapter is pretty frequent. Then decorator is frequent. Yes. Facade, proxy, right? Then we have observer, right? Observer pattern. So is there any other pattern that is very similar to observer pattern? The pub sub pattern, right? The pub sub pattern. Now, a lot of people think that these are exactly the same. There's a slight difference between the observer and the pub sub pattern. We have strategy pattern. Right? You will see this very frequently. You have state pattern. You have the mentor pattern. Right? Apart from that, we have the chain of responsibility. Chain of responsibility. Right? You have the strategy pattern. So we have already covered strategy. You have MVC architecture. Right? You have the visitor pattern. You have tons and tons of patterns. Right now, all of these patterns, each and every one of these patterns, they serve a specific purpose. Each and every one of these, they serve a specific purpose. And yes, you are expected to know each and every one of them. All right. Just saying that, okay, I know these basic ones, factory, builder, singleton, that is not good enough. You have to understand what these patterns are, and you have to understand how to apply them. Because when you actually go and look at the code of large scale systems, of large scale applications, you will actually see all of these patterns being applied. Perhaps you will not code these patterns yourself, right? Perhaps someone else who has created the code already, right? You will usually be working on some existing code. So you will encounter these patterns all over the place in the existing code. And unless you know what that pattern is, you will not be able to understand how this works, right? Things will not make sense to you. So you have to understand what these patterns are and how to apply them. Does that make sense? Yes. Anshuman has raised his hand. So Anshuman has a question. Let us quickly see what question Anshuman has. Okay, we are getting a lot of questions. Let's not unmute anyone. Let's just see from the chat itself. Okay. All right. So in design patterns, in low-level design, we have to cover object-oriented programming. We have to cover design patterns. What else comes under low-level design? So some other concepts. So for example, whatever framework you're using, so a framework like Spring, that has a very core concepts, right? So two very core concepts that Spring framework uses. What are those? It has dependency injection, right? And inversion of control. Right? Now, just knowing that, okay, Spring uses dependency injection and inversion of control, that is not enough. You have to understand what dependency injection is. You have to understand why you want to use it. Right? You have to understand what inversion of control is and why you want to use it. There's a lot of things over here. Okay. Now, this is 1 month. This is 1 month of LLD. Right? Apart from that, we also have to look at project building. Right? We spend another 1 month on this. Now, what does project building, what all things does project building have? So you need to understand what the MVC pattern is, right? What different patterns are. You need to understand what REST APIs are. Yes. You need to understand how to create the database schemas, how to normalize the database, right? How to perform indexing on a database. Yes. You need to understand how to configure, test, and deploy your application. Right? Deploy your application. Right? You need to understand what the normal tools are, right? So how to do dependency management, how to do version control. So these are all the things that you need to know to become a successful programmer. Right? Now, this is what we have in the Scalar curriculum, this project building part. We have 3 months over there. Now, we do not have 3 months on Saturday and Sunday. Right? We just have 8 hours on Saturday and Sunday. So what we are going to do is we are going to try to do these things. We are going to skip the high-level design. We are not going to do this in this class, but we are going to try to cover as much as possible from this low-level design curriculum and this project building curriculum. Okay, and we are going to somehow compress that down into 8 hours. Does that make sense? Now, of course, that there's a lot of material to cover, so we will not be able to cover all of them. Right? We will not be able to cover all of them. We will try to cover the basics of object-oriented programming. We will try to cover simple patterns like, in this case, we will cover the strategy pattern, right? And we will cover things like the builder pattern and the singleton pattern, right? Apart from that, we will cover how to build REST APIs, what MVC is, how to create the database schema, right? And we will actually configure, test, deploy our code, and we'll create the code. Okay, so that is what we plan to be able to cover in the next in this masterclass. Okay, so does that answer your question about what the curriculum is going to be about? Yes, perfect. Now that was a lot of chat. Now let us begin with object-oriented programming. Okay, cool. So what is the crux of object-oriented programming? Let us first start with what we usually do. If we are not doing object-oriented programming, then what other things are we usually doing? So, I mean, if you're working on a small project, then you will be writing all code in one file. Yes. Well, you might split the code into multiple functions. You will see that, okay, whenever something needs to be repeated or whenever something makes logical sense separately, I will split it down into a function. But other than that, your code will still be in one file and your code will be all over the place, right? So contrasting with that, we have a different paradigm of thinking of things, right? So first of all, before we talk about object-oriented paradigm, what other paradigms exist? So this is basically the procedural. Apart from that, we have functional programming, right? What else do we have? We have event-driven. Yes, we have data-oriented. Okay. We have aspect-oriented. Reactive, well, reactive comes under most of these things. We have declarative, right? So something like SQL or something like Prolog. Right? So there's a lot of different patterns over here. There's a lot of different programming paradigms over here. The more paradigms you're familiar with, the better it will be. But if you look at the majority of the software landscape, then object-oriented programming, right? Object-oriented programming is still the most used programming paradigm. Okay, whatever language you come across, I mean, most of the major languages, C++, Java, Python, Ruby, right, JavaScript, all of these support object-oriented programming to some extent. Does that make sense? Yes. All right. Cool. So this is what object-oriented programming is. Now, object-oriented programming talks about several things. It talks about classes. It talks about objects. Right. It talks about abstraction and encapsulation. Right. Now let us quickly look at what these different things are. Okay. So what are classes? So as the title over here says, classes are prototypes. Right? Classes are prototypes. For example, let us say that we are talking about a board. Right? Now, board over here is a concept. Board is a concept. When I'm talking about a board, I'm not really talking about a kiwi. I'm not really talking about a chicken. I'm not really talking about a sparrow. Right? I am talking about the general concept, the general idea of a board. Does that make sense? So if I'm talking about a board, what things will the board have? The board will have some attributes. Yes, attributes. What can the attributes look like? The attributes can look like the weight, the color. Yes, it can be the wingspan. Right? It will have some functions, right? Functionalities. It will have some functionalities. Yes. So for example, the bird can fly, exactly. The bird can eat, the bird can reproduce, and so on and so forth. The bird can sleep, and so on and so forth. Yes. Apart from that, what else will it have? Now there's a slight difference. So you understand that there are attributes, but apart from attributes, there are also some other things. There are some dependencies. And there are some relationships. Right? What do we mean by dependencies and relationships? For example, a bird has a wing. Right? A bird has wings. Right? A bird has a beak. Does that make sense? So to properly function, a bird will require some sort of a beak. To properly function, the bird will require some sort of wings. To properly function, the bird will require some sort of eyes. Now, eyes comes in various flavors. Right? In different birds, we have different types of wings, different types of beaks, different types of eyes. So these are kind of dependencies or relationships of bird to other entities, right? To other concepts. Does that make sense? Yes. Okay. So can someone tell me what a concept will be? So if I'm talking about, let's say, this Apple Pencil. So if I'm talking about this Apple Pencil, then what concept, what is the class for this Apple Pencil? So if I want to talk about this Apple Pencil, then what concept or what abstraction should I be looking for? I should be looking for the abstraction of pencil, right? Or I should be looking for the abstraction of Apple Pencil. Yes, that will be the name of my class. Okay, so these classes, they define the prototype. They define the idea of how to think about something. Now, if you just think in the abstract sense, if you're just living in the abstract sense, you will not be able to solve a lot of problems, right? To solve the problems, you have to have some level of abstraction, but you also need to talk about concrete things. Does that make sense? So if I want to talk about this pencil, right, this particular pencil, it is not the case that I'm talking about an Apple pencil. It is not the case that I'm talking about any white pencil. I'm talking about this pencil, this exact pencil that is currently in my hand. Does that make sense? So basically, we have classes. Classes are the blueprints. Right? When we actually create something out of that class, once we instantiate a class, what we get is a object. Does that make sense? We get an actual implementation of that concept. Does that make sense, guys? Yes. How do you create an object? So let us say that let us talk about something like Java. Right? So let us say that we have a class called bird. Right? It has some things. If you want to create an object, we will say bird, some b, this is the variable name, equals to new bird. Right? We will use a new keyword. Does that make sense? If you are doing something like in Python, then we will have the class bird, right? And we will say b equals to bird. Right? This is how we instantiate and basically create an instance of a class. And what is this called? So what are we doing over here? We're calling the constructor. Right? We're calling the constructor of the class. Does that make sense? Yes. Now there's a lot of details over here. What the constructor is, what the initializer is, right? I mean, how to create the objects, what sort of objects can exist, right? So we will not have time to go into the depth of this. If you want to go into the depth of this, feel free to learn more about object-oriented programming. Okay, there's a lot in object-oriented programming. Now after that, we have inheritance. Now what we see is, we just said that this is an Apple Pencil, right? This is an Apple Pencil. Well, is that the only concept that I can talk about? So this Apple Pencil, this also has some other abstractions, right? So this can be just called a pencil, or this can be called a digital pencil, right? And so on and so forth. Yes, or it can be called an Apple product. Yes, I can talk about this Apple Pencil in multiple abstractions. So what we usually have is, we have a hierarchy. We have a hierarchy of concepts. So we can have something like this. We can have a hierarchy called pencil, right? Or we can have on top of it, we can have writing tools, right? So writing tools is a concept. So for example, a pen is a writing tool, right? A typewriter is a writing tool. So similarly, a pencil is also a writing tool. Does that make sense? So both of these are concepts, but there's a hierarchy of these concepts, right? Similarly, Apple products is a concept, right? So let me just write this over here. So we have writing tools, right? Inside this we have pencil. Now we have Apple products, right? In this I have iPencil, right? Now pencil and iPencil, they together give me an Apple Pencil, a class for this particular pencil. Does that make sense? Yes. Right? So I can have a lot of different abstracts. So basically, this iPencil over here, this will be like this. Sorry, iPencil. Right? An iPencil is a pencil, and it is an Apple product. So Apple product is itself a concept. It is not a concrete object. Similarly, writing tool is itself a concept. It is not a concrete object. This iPencil is also a concept. It is not a concrete object. The concrete object is this pencil. Right? This is, so basically, if I instantiate this, an instance of iPencil, the one that I'm currently holding, that is an object, and the rest are concepts. And these concepts exist in a hierarchy, and that hierarchy, that we build that hierarchy using something called inheritance. Does that make sense? Yes. Now, what does inheritance really tell us? Inheritance tells us that if there's a class A, and there's a class B, then if class B inherits from A, then all the properties, all the different attributes, and all the default behaviors of A will also be present in B. Does that make sense? Yes, no? Okay. Now I see a very common question over here. We will just answer that question. Okay. So a lot of you have already started asking me that Java doesn't allow multiple inheritance. Multiple inheritance. So let us first of all talk about what on earth multiple inheritance is. So just like we had over here, right? So we have an iPencil. This iPencil inherits from both pencil and Apple product. Right? So basically, iPencil has the properties and attributes of both a pencil and of an Apple product. Right? Now, this is called a multiple inheritance. So iPencil inherits from both pencil and Apple product. Now, Java does not really allow multiple inheritance. What language are you familiar with that allow multiple inheritance? Is there any language that allows it? C++ does. Python does. Right? There are many other languages. So I think Scala, I'm not really sure about Scala. I'm not really sure if JS allows multiple inheritance either. So there's a lot of languages that allow multiple inheritance. Java does not allow multiple inheritance. Right? There's no multiple inheritance in Java. Okay. What other things do we have? So multiple inheritance is usually frowned upon. Yes, people don't really like multiple inheritance, and the reason for that is there's a lot of confusion and ambiguity. Right. More specifically, there's this diamond problem that we run into. Right now, we are not going to discuss the diamond problem today. I mean, if you want to learn about it, feel free to Google and learn about diamond problem. But this is a very real problem, and different languages approach this in different manners. For example, to handle the diamond problem, Python has come up with an idea of the method resolution order, right? The Dunder MRO. C++ has other techniques as well. Java simply says that, okay, you're not allowed to have multiple inheritance. But you still want to have something like this, right? You still want to express this relationship that an iPencil is also a pencil and an Apple product. So how do you describe this relationship in something like Java? And the answer to that is interfaces. Right? The answer to that is interfaces. Interfaces basically help us, instead of doing inheritance, it helps us do composition. Does that make sense? Yes. So what is the difference between an interface and a class in Java? What is the most common differences between an interface and a class? So let us say interface versus class. I cannot instantiate an interface. Exactly. There is no objects. I cannot create an object of an interface. An interface is an abstract concept. An interface is an abstract concept. You first have to implement that interface. You have to have a concept that implements that interface, and then you can construct an object. Right? For a class, you can make an object. Right? You can make an object. Right? What else? An interface cannot really have any sort of attributes. All right? Interfaces only have behaviors. They only have behavior. Basically, an interface is some sort of a contract. Right? Interface is some sort of a contract that you are enforcing. Does that make sense? Whereas classes can have attributes, classes can have behavior as well. Does that make sense? Yes, no? All right, cool. So these are some of the differences between interfaces and classes. And once again, the differences is that you can implement multiple interfaces, but you can inherit from only one class. Yes, that is another very important difference. Okay. So let us move on. What are abstract classes? What are abstract classes? What are abstract classes? Well, abstract classes are basically, once again, these are concepts, right? These are concepts. But just like interfaces, you cannot instantiate them. Right? Basically, these are incomplete blueprints. Right? For example, the class board that we had. Can you really create an object of a bird class? Can you really create the object of a bird class? Perhaps you cannot. Right? This is an abstract class. If you want to create a bird, you will have to specify what the species of that bird is. Right? So you will have a class, let's say eagle, that inherits from the class bird, right? Extends bird. And then you can create the object of an eagle. An eagle will also be, the object of an eagle will be an eagle. It will also be a bird. But you cannot directly create a bird because this blueprint is incomplete. Does that make sense? The bird blueprint is incomplete. We have to complete that blueprint by defining another blueprint. That is what we mean by an abstract class. All right? Perfect. What about encapsulation? What is encapsulation? Encapsulation, so you might all have heard of this. Encapsulation is data hiding. Let me change the pen color. Encapsulation is data hiding. Yes. What do we mean by hiding data? It means that having control over your data. Basically, if I have a class, that class will rely on some attributes. That class will rely on some things to work properly. Yes. Now we don't want any external entity to be able to change the internal behavior of a class. Does that make sense? So for example, let us say that you have a class square. Yes. And let us take a different example perhaps. Let us say that you have a class rectangle. Right? Inside this class rectangle, you have an int width and you have an int height. Does that make sense? All right. Now for a rectangle, it is fine if we change the width and the height. Right? Basically, we can calculate the area over here. We can have a function int area, and this can just return w into h. Yes, this is what a rectangle class will look like. And for this rectangle class, it totally makes sense for someone else to come and modify the height, width, and modify the height. That is clear, right? But let us talk about a class called a square. Every square is a rectangle. Do you guys agree? Every square is also a rectangle. So this would extend from the rectangle class. All right. But when we are talking about the square thing, is it a good idea for someone to say that, okay, if I have a square object, square sq equals to new square, is it a good idea for me to say sq.w equals to 10, sq.h equals to 20? Is this a good idea? No, right? Because in a square, we are enforcing some constraints. We are saying that the width and the height, they must always be the same. Yes. So to prevent someone else, to prevent some external entity from freely modifying our data, we have to hide. We need to hide these internal attributes. Yes, we need to hide these internal attributes. So basically, Java provides us several things for encapsulation. We have several access modifiers. So things like private, protected, public, right? Package private, things like that. And we apply these access modifiers to several attributes and also to functions, to methods. Does that make sense? We can have private attributes. We can have private functions as well, so that others, external entities, cannot use them. Does that make sense? Yes. So these are some of the basics of object-oriented programming. Now let us jump to the core of our material. We want to design Uber today. Okay, we want to design Uber today. Saurabh says finally. So guys, I also see a lot of questions about the break. So basically, last time I took this class on Book My Show, right? And in the Book My Show as well, we had taken a break. But no, we are not taking a break right now. I just want to tell you a story. So there was this one girl who approached me on LinkedIn, and she basically said that, your class was really wonderful, right? I really enjoyed the class. And she said the best part was at 2:40, right? So 2 hours and 40 minutes into the lecture, that was the best part. So I was like, okay, that's very specific. I thanked her. Thank you. But that was very specific. I need to go back and review the lecture and see what really happened at 2:40. And can you guess what happened at 2:40? We started the break. Yes. So I know that most of you are very anxious for the break. So let us just say that after we do this basic requirements analysis of Uber, then we'll take a break. All right? Perfect. All right. Cool. So when we talk about a system, what do we usually talk about? So let's talk about an interview scenario, right? In an interview scenario, what you will get is a very vague question, something like designing Uber. Harshvardhan, you will not be able to get the recording of this class. Please, so guys, please don't spam. Okay. Cool. So let us say that you are in an interview scenario, or let us say that you are the CTO, right? You are the CTO for a particular startup, and your CEO has given you a requirement. Your CEO has given you an idea. That person has a vision, right? And he tells that, okay, we need to create an application that allows people to book cabs, right? To have cab sharing, right? Now this is a very vague idea, right? You have a very vague description, or you have some sort of a vision. There's nothing concrete over here, right? This is what real life problems actually look like. This is what real life problems actually look like. Nobody in the real life, nobody comes and says that, okay, this is exactly what you have to implement, and this is how you have to implement it. Right? You don't have that. You don't have that privilege, right? Even so, basically in interviews as well, what the interviewer will do is the interviewer will give you a very vague requirement. So something like design Uber, something like design Uber. Perhaps the interview will try to verify that you actually have used Uber, so you will know what the context is. But the problem statement will be just this: design Uber, right? So when you have a problem statement like this, what do you start doing? How do you even approach this problem? Should we start coding? Yes. No, we should not start coding, right? Because this problem is not concrete. This problem is not concrete. We first have to figure out what the problem is in the first place, right? So what we have to do is we have to gather requirements. Gather requirements. Right? Once we have gathered requirements, what do? We break this project down into executable modules, right? Into different parts. So basically, we talk about what the classes are, what their relationships are, right? Basically, the ER diagram. Right? We talk about how the database will be, basically what the schema of the database will be. We talk about the responsibilities of the system, right? We talk about the features and responsibilities of the system. Yes. Apart from that, we talk about the actors in the system, the use cases. We talk about a ton of different things, right? We talk about, okay, what the architecture, what the high level architecture of the system is. Right? We talk about what individual modules do we have, what services do we have. Does that make sense? Yes. So a lot of things go into handling a question like this. So let us take one of these questions. Let us say that our question is that we have to design Uber. So the first step that we have to do is we have to gather the requirements. Okay. So let us work with some requirements. Let us say that we have some basic requirements. Okay, we have requirements like that riders can book a cab. I mean, it will not be much of Uber if the riders cannot book a cab, right? So this is one of the basic requirements that you have. Okay. Then perhaps another requirement is that riders can see the nearby cab locations. So all of you have been to that Uber screen, right? All of you have been to that Uber screen. So it will show you your current location. This is your current location. And apart from that, it will show you, okay, what the map is. And it will show you that, okay, there's a car over here. There's a car over here. There's a car over here. And it will show you that a lot of cars are available around us. Yes. And then you will be able to book a cab. Yes. So basically riders should be able to see what nearby cabs are available. Okay. Now, currently you are just seeing these cabs, right? Currently you're just seeing these cabs. Is any of the driver seeing you? Can any of the drivers see you? No, the drivers can't see you, right? Because the drivers are just driving their cabs. They have some other customer that they attend to. The driver should not be able to see. The driver should not be able to see what customers. What customers are available. Right? Only when a request is raised, only when a request is raised and the request is accepted by a driver, only then should the driver be able to see the client's position. Yes. So once a request is booked, once a cab is booked, then both the driver and the rider can see each other's location in real time. Right? And this will happen till the ride finishes. Does that make sense? Yes. Okay. Well, when we are talking about a cab booking service, we need to have some security with us, right? We need to have some sort of identification. We need to know who the driver is. We need to know what their rating is. We need to know what sort of cab they're driving. Right? We need to know what the license plate number of that cab is, what is the color of that cab, or how else will we identify that? right? We need to know what the build and make of that cab is. All these different things. Yes. Yes. So we need to have these details. Well, apart from that, when we actually select one of the services, right? When we see that, okay, I want to book an Uber XL, right? And I click book or basically find rides, then what happens? What happens? Is it going to show me all the possible rides across the world? No, right? It should show me only nearby rides, because hey, if I tell someone to come from America, right, to give me a cab ride over here, that is not going to work. Right? Similarly, I can't fetch a driver from Delhi, right, to give me a cab ride in Bangalore. Okay, so I have to fetch the nearby rides. So this is one of the requirement, that whenever booking a cab, only cabs within some maximum radius they are shown. Okay. Now this is still a very vague requirement. What do we mean by maximum radius? How large is the maximum radius? What about dense areas? There's a lot of things that we need to consider over here, but this is one of the requirements. Yes. Okay. Then we have some way that the estimated time to arrival is calculated. Right. So basically, let us say that the thing knows that your cab is over here, right, and your passenger, your rider is over here, right? And there is, let's say, 2 kilometers of distance between. Now, usually the way Uber will calculate the distance will not be this Euclidean distance, right? This is just the distance between them. This is just the displacement between them. The Uber will actually have to look at some map service and figure out what the route between these rider and the cab is. Yes, they will have to figure out what traffic is, what weather there is, right? They will have to look at a lot of things. So, what is the average speed of that particular driver? Yes, is there any traffic jam over here? Right? They will have to consider a lot of things. So, I mean, you can go into a lot of details, but for this project, we are going to keep things simple. We are going to say that the ETA will be calculated just based on the Euclidean distance plus 50%. Okay, so the driver will have some sort of a speed. We will know the distance between these 2 points, and we will say that, okay, whatever time is, the time is just the time it will take to cover the Euclidean distance plus some 50%. Okay, all right. Another requirement is that we should have multiple types of bookings. Okay, we should have multiple types of bookings. So it is not just the case that I can just book one car. Like Uber supports a lot of different car types. I can book an XL. I can book an Uber pool. Right. So Uber pool is some sharing thing. Just like Ola has Ola Share. Right. Lyft has something else. So Uber pool is the sharing thing. I can have Uber Prime. Right. Uber Prime has other benefits, so you can listen to songs and stuff like that. There's Uber Go, and there's also Uber Outstation. Does that make sense? Yes, so these are some requirements. Apart from that, of course, the drivers and the riders, they should be able to register to your application. Right? What good is an application if the number of users does not grow? Yes, so we have to take care of this. Well, when the driver is on the move, I need to update the driver's location. Right? I need to update where the cab is. And this needs to happen every so frequently. Yes, because the cab can be moving at a very high speed. Right? And the application will have some sort of a GPS tracker, and I need to keep the server updated that, okay, every 10 seconds the location needs to be updated. Yes, this is one of the requirements. This is a very heavy requirement, right? Mind you, if you have let's say 100,000 drivers, then in 100,000 drivers they are basically sending one request every 10 seconds. Isn't 10 seconds too long? Karthik is asking. Yes. So in actuality, for something like Uber, you will actually have 3 seconds of delay. Right? The driver will actually ping in 3 seconds. Right? Okay. Well, the driver should be able to go on a break. Right? You can't expect the driver to be working 24/7. So that if the driver wants to go basically for a dinner, right, or for a lunch, then the driver should be able to mark that, okay, I am not available on this point. And when the driver comes back, they can turn on their availability once again. Yes. Okay. Then the rider should be able to see the history of his bookings, right? His or her bookings, and what the upcoming bookings are. So basically, when you're booking a ride, you can either book the ride for now, or you can book the ride for future as well. Right? You can book multiple rides as well. And also, once you have completed a ride, that ride should not go away. You should be able to track in your application itself that, okay, you had taken these rides earlier. These were the ratings you had given for the rides, and these were the locations that your rides were for. Yes? All right. Okay. One of the requirements will be that the driver will be able to end the trip. Yes, driver will be able to end the trip. We can add a requirement that the rider should be able to cancel the trip. Yes. Okay. We will have a requirement like OTP. So what about OTP? How does OTP really work in Uber? So before you start a ride, before the driver can mark that the ride has started, you need to share the OTP with the driver. Yes, you need to share the OTP with the driver. Similarly, when the ride is completed, so I'm not really sure if that happens in Uber, but I think when the ride is completed, you again give an OTP. Right? It's for Ola. It's for Ola. So let's have this. Right? This basically has a lot of security. This makes sure that the driver cannot really start the ride at any arbitrary point. Yes. And once again, when a rider says that, okay, I want to book a cab from this location to that location, we will try to find out all the nearby drivers. Right? But the driver needs to accept. The driver needs to accept the particular ride. Right? You can't force a driver to go from one place to another. Does that make sense? Yes. Okay, so these are some of the requirements. These are some of the requirements that we have collected based on a discussion. Now, this discussion could be with our CEO. This discussion could be with the interviewer. Right? Now, these are the requirements that we have collected. Of course, these are not all the requirements. So, as all of you are pointing out, we have to make payment. Right? We have to figure out what the pricing strategy is. Right? We have to figure out how will a driver be matched with a particular rider. So, there's a lot of things over here that are still not clear. Right? And that is our job to basically clear these up and figure out what the different features of an application are going to be. Does that make sense? Yes. These are some requirements. We have to stick to these requirements. We have to make sure that at least these requirements are done properly. Apart from that, if we find that something is useful for us or something is basically critical, then we can implement that as well. Right? But these are the requirements that we have been given, and from the client side, and we have to at least make sure that these requirements are in place and these should be working properly. Does that make sense, guys? Yes. Okay. So let us quickly take a pause over here and let us quickly see if we have any questions. I think that we had lots of questions in the middle and I kind of skipped that. Deepika is asking, what is the duration of the LLD round? So Deepika, that depends a lot from company to company. It can be 1 hour, it can be 2 hours, it can up to be even with 3 hours. Right? So I think in companies like Gojek, they have a 3-hour low-level design round. So you don't really have to worry when you're discussing the requirements. When you're discussing the requirements, your interviewer will tell you that, okay, is this a good requirement to have or is this not a good requirement to have? Okay, so you start by listing down the requirements, okay, and you try to define the requirements, the most critical requirements first. Right? And the interviewer will be there to help you that, okay, let us take this or let us skip this. This will be too complicated. Is that clear? Yes. Disha is asking, is low-level design related to competitive programming or are they two different routes? So Disha, low-level design is completely separate from competitive programming, right? And that is one of the issues that a lot of people face. People think that just by doing a lot of competitive programming, just if I'm a 5-star coder at CodeChef, then I will get a very high-paying job. That is not true. Being able to solve problems is one thing, but being able to do it elegantly, being able to write the code for it is different. Right? Algorithms is not the entire of computer science. Algorithms is a part of computer science. So companies look for your competitive programming skills and also your low-level design skills. Okay, so these are two separate things. All right. Shubham is asking, will we divide functional and non-functional requirements going on? So Shubham, we will not be making a specific distinction between them. When we go hands-on with the code, we will see what all things we'll be able to implement. Okay. Mosami is asking, are we expected to write working solutions for these requirements in the interview? Well, Mosami, yes and no. Basically, you don't have to consider all these requirements. Right? Once again, your interview will be there to help you, and the interview will tell you that, okay, these are some of the requirements that we definitely need to implement, and these requirements perhaps we can skip. Right? Now, for the critical requirements, for the requirements that you actually have to implement, yes, you will have to implement a working solution for those. Okay. All right. I think we missed something, that is estimated cost and final cost. So Shubhakar is saying that I think we missed the estimated cost and the final cost calculation of the day. So yes, Shubhakar, that is not part of the requirements. Right? That is not part of the requirements. But if we think about any cab booking service, that is a critical part. Right? That is a critical part. So that is not present in the requirement. That's a hidden requirement that we have to consider. All right. Perfect. So I hope that I have answered most of your questions. Now that we have done this, now that we have listed out the requirements, now what should we do? What should we do now? We should figure out what the entities are, what the actors are, and what the relationship between these are. Yes, what the entities, actors, and relationships are. So first of all, can someone tell me what the actors will be in this system? What actors will be in this system? So actors. We have rider. We have driver. Anything else? We have some sort of an admin users, right? So let's say employee, internal employee. Right? These are three actors that we have on the system. Anything else? Is car an actor? Not really. A car cannot really act on its own. Right? A car, the driver controls the car. Right? The driver controls the car. Okay. So these are the major actors that we have. Okay. Once we have the actors, let us try to list down entities. Let us try to list down the entities. Now, what is one good way of detecting entities? There's a good pattern over here to detect entities. Yes, as most of you are aware, it is finding the nouns. Right? It is finding the nouns. So let us quickly go through our requirements and let us try to identify what nouns exist over here. Right? And we will try to mark all those nouns. So yes, in the first requirement, do we see any nouns? Rider is a noun. Cab is a noun. All right. In the second requirement, do we see any things? Location. Location could perhaps be an entity. Right? This we are not really sure about this, but location could be an entity. Okay. All right. Once booked, both the rider and driver can see each other's location until the ride finishes. Do we have anything over there? We have a booking. Right? In all these three requirements, we see that there's it is not explicitly written over here, but there's an entity called booking. Right? Or basically a ride. Yes. Okay. Then let us look at the next requirement. Each cab must have details like license, color, brand, driver details. So any entity over here, is license going to be an entity? Well, it could be, it could not be. Right? We could split that into a different class, but we don't really have to. Well, one thing that we would definitely want to distinguish over here would be the driver and the cab. Now, a driver cannot give you a cab ride without having a cab. And similarly, a cab basically cannot drive itself. Right? We don't really support self-driving cars over here. So there's kind of a one-to-one relationship between a driver and a cab, but these things are still separate enough that we would want to keep them separate. Right? A driver is an actor. A cab is a tool that a driver is using. Does that make sense? Every driver will have a cab and every cab will have a driver. Does that make sense? But these will still be separate entities. Okay. Let us move on to the next requirement. When booking, only cabs within a maximum radius are shown. Is there any entity over here? Is distance going to be an entity? Distance is a property, right, of two entities. It's a relationship between two properties. It's not really a entity. Radius is not an entity. Radius is not an entity. Map, once again, not an entity over here. Geofence, not an entity over here. Okay. All right. Let us move on to the next one. ETA is calculated based on Euclidean distance. Is there any entity over here? Yes, no. Well, we don't have an entity over here, but do we have something else? We see a service over here, right? Something like a pricing strategy, or basically a ETA strategy. Right? ETA strategy. Yes. Yes, this is ETA service basically. Okay, let us move on then. We have this requirement. Multiple types of bookings: XL, pool, prime, go, outstation. What do we see over here? We see a cab type, right? We see a cab type. So this can perhaps be done using an enumeration. Okay, so cab can have a type, cab type. Or if the behavior of different cabs is very different, then this could also be an inheritance model. Does that make sense? This could also be an inheritance model. Yes. Currently, let us not try to define which one we are going to use. When we actually go into the code, then we can decide, okay, should we go with the inheritance thing? Should we go with the enumeration thing based on the rest of our code? right? But we see that, okay, we are going to have some sort of an entity over here, some sort of a hierarchy over here, all right? Perfect, let us move on. So in this requirement, what do we have? Any entities, any new entities over here? No, but we see an API, right? We see a registration, and an authentication service, auth service. Yes, we'll have a complete API for registration, for handling the profile, for changing things. We will have some sort of security so that only authenticated users can work with the system. So if I am a rider, I should not be able to change your rights, right? So there should be some access control over there. All right. I need to have some sort of, so the cap needs to update the location every 10 seconds. What about this? Are there any entities over here? Are there any entities over here? No, but I have a lot of services over here, right? So I have a service that basically the cap can ping to, right? So basically a location service, right? So using this service, the cap will fetch its location. I will have a service like a tracking service, right? Tracking service. So this service will be exposed both to the rider and to the driver, right? So basically, using this tracking service, the rider can find out what cabs are in my locality. Does that make sense? Yes, what cabs are in my locality, and so on and so forth. Okay, let us move on to the next one. Driver can turn off his availability. So do we see anything over here? This is not an entity. This could be perhaps a status, or this could be just a property, right? So it could be just a Boolean value, available or not, right? Just a simple property works over here. The next thing, rider can see their bookings, the history of their bookings. So do we see anything over here? Booking history. Should that be a separate entity? Should the booking history be a separate entity? No, right? We have bookings already. A rider can have multiple bookings. To get the history, we just have to fetch those bookings that are related to a driver, to a rider. Right? This does not need to be a separate. This does not need to be a separate entity. Okay, let's move on. Driver can end the trip. Any entities over here? Yes, we have an important thing over here. We have the trip status, right? Trip state, basically trip state. Now the trip state can be multiple things. The trip state can be perhaps it is cancelled, right? Perhaps it could be, so the driver could be, so basically the cab arrived. The cab could be, the ride could be in progress, right? It could be that the ride has ended, yes, and the payment is pending, or it could be that the payment has already been done, right? Anytime payment, yes. We can have several states over here. It could be scheduled in the future. Right? It could be a schedule in the future, so basically future. So we can have multiple states over here, and we will see some sort of a state pattern over here. Does that make sense? Yes. Okay. What about OTP? Is there any entity over here? Well, we have an OTP service, definitely. An OTP service will be there. But an OTP will also be an entity. Right? An OTP will also be an entity. Basically, when you send an OTP to someone, that OTP should be saved in your database as well. Right? Otherwise, how will you verify whether the person has entered the correct OTP or not? Yes. So OTP is basically a token that you will also have to save in your database. So yes, this is also an entity. Right? OTP is an entity. Okay. All right, let's move on. Driver must accept the right. Any entity over here? No, there's no entity over here. There's no entity over here. Okay, so we have identified some of the entities that we have. Okay, so let us quickly write down the entities that we have identified. So we have a driver, we have a cab, we have a rider, right? Then we have what else? We have a booking. We have a location. All right. What else do we have? We have an OTP. We have a ride status. Okay. Then we have the cab type. Okay, we have the cab type. So these are some of the entities that we found from our requirements. Are there any other entities though? trip, user, right, that are already covered, right? Admin. So basically, we also saw that in the actors, we had one more actor, right? This was not part of our requirements, but this is critical. So we need some sort of an admin. It could be just one admin interface, or it could be multiple employees that will interact with the system, right? That are internal entities. So we need to have an entity for that as well. Right? Let us just call this admin entity. Admin entity. Does that make sense? VG is asking why is cap type an entity? So cap type could be just an enumeration. Cap type could just be an enumeration. So currently we are not deciding whether all of these will be mapped to the database or not. Currently we are not really deciding whether all of these will be mapped to the database or not. It could be the case that cap type is just stored as an enumeration. Okay, it is not mapped to the database. All right. What about payment? Exactly. So basically, apart from this, we have one more very important hidden requirement, right? And that is payment. Payment, right? With payment, what sort of entities will come associated with this? So with payment, I will have a payment gateway. Yes. Apart from that, what will I have? I will have a payment receipt, right? I will have a payment receipt, or basically some sort of an invoice, right? Or transaction history. Exactly. So these are entities. Apart from this, I will also have a payment service. So that is not an entity, but I will have some sort of a payment service. Yes. All right. Perfect. What else do we have? What else do we have? So these are the most important entities that we require. Apart from that, we can have tons of other entities. So we can have something like when you actually go to Uber, you see some sort of rating for the rider, right? Exactly. So you see some sort of rating. So the ratings are not just for the rider; they're also for the customer. They're also for the customer. Right? For the driver and the rider, you have ratings. Yes, you can have feedbacks. That can be an entity. You can have many other entities. Right? You can have many other entities. Is notification going to be an entity? Not really. Okay, notification is not going to be an entity. Wallet could be an entity. It could be the case that for Uber, you can already save some money in your wallet. Right? You can save some money in your wallet, so wallet can be an entity. So there can be a lot of other entities. Let us not complicate all those things. Let us not decide all those things. Let us keep our entities to these things. Okay, let us keep our entities to this. All right. Once we have the entities, what should we do? OTP, I've already written OTP. Once we have these entities, what should we do? We should talk about the attributes, the behaviors, and the relationships of these entities. Yes? The attributes, behaviors, and relationships of these entities. So let us talk about driver. What attributes will it have? What attributes will a driver have? They will have a name. All right. They will have a license. Right. They will have a phone number. Yes. Okay. Let's talk about cab. What attributes does a cab have? So ratings, we can have ratings in the driver or the cab, but we are skipping ratings. Right? We can totally have ratings, but we are currently skipping this to keep it simple enough. Right? We remember we actually have to implement all of this. Okay. So let us not take more than we can chew for tomorrow. Cab is going to have a license plate number, right? A cab is going to have a brand and model. Yes. It is going to have a color. What else? It is going to have a size. So is it XL or normal? Right? Or is it a sedan? Right? So it will have a cab type basically. So that comes under model perhaps. Okay. What else do we have? We will have an AC, non-AC, things like this. So you can have multiple things over here in the cab as well. Right? You can have multiple things over here in the cab as well. Is there any availability? Right? Availability. So should that be in the cab or should that be in the driver? It should be in the driver, right? Availability. Okay. Cool. Cab will have a capacity. Sure enough. Cab should have a location. Cab should have a location, but it is not really an attribute of the cab. It is a relationship. So notice that location is a separate entity. Right? Location is a separate entity. So cab will have a relationship with a location. Does that make sense? All right. Cool. Then let us talk about the rest of the things. So we have rider. Right? So we have rider. So what attributes do we think rider will have? Once again, name. Right? They will have a phone number. Yes, they will have some basic details. So maybe they have some details for the security. They will have a gender. Yes, they can have several other things. So maybe a rider has a profile. The rider has a preferred payment method, right? The rider has a basically the preferred cab type, and so on and so forth. The rider can have tons of different things as well. All right. Okay. What else? Let us talk about the trip, or basically the booking part. Yes. So what attributes will a trip have? It will have an origin. It will have an origin. It will have a destination. Okay. It will have some sort of a payment info, right? It will have an estimated cost. Estimated cost. It will have a final cost. It will have a trip type, right? Trip type. So basically, is it an outstation trip, or is it a rental, or is it a shared booking, right? Things like that. All right. Should path be part of this trip? Do I really have to store the path? Well, I can or I cannot. So if you look at something like Uber, if you go back to the history, then you can actually see what path the trip had taken. Right? But let us keep things simple over here. Let us not fix that. Right? Let us not save that. All right. A trip will have a trip state, a trip status. Right? So basically, is the trip active? Is the trip currently ended? Things like that. Yes. Trip will have OTPs. Now, once again, these will be relationships. Right? So several things over here. Something like origin, something like destination. These will be relationships. Relationships. Okay. Does that make sense? Because location is a separate entity. Does that make sense, guys? Yes. Okay. So these are some attributes of the trip and booking. What other things do we have? Location. In location, what attributes can we have? We can have the XY coordinates, right? So the latitude and the longitude coordinates. What else? We can have some sort of a zip code as well. Yes, we can have some sort of a zip code as well. We can have some sort of a landmark. We can have some sort of a name of what really exists at that point. Right? We can have city, state, country, all these informations. Yes. Okay. Then, so these are some of the entities that we have. These are some of the entities that we have. Okay. Now, apart from these entities, most of these entities are going to be saved in the database. Right? Most of these entities are going to be saved in the database. But apart from that, do we see any sort of services? Services or any other classes that we will need to create? We saw some of those, right? So we saw that will have an OTP service. Right? We will have a registration service. Yes, we will have a payment service. We will have a pricing strategy. Pricing strategy, right? We will have a booking strategy, right? So basically finding strategy. So something like matching strategy, right? So this will match a driver to a particular rider. Matching strategy. Yes. What else can we think of? Tracking history service. History is not really a service. ETA service. ETA service. Yes, we have an ETA service strategy. Okay. So these are some of the. We will have a notification strategy. Right. We will have a notification service. Notification service. Right. Login and log out. Definitely. So that will come under registration. Login, log out, and authentication will come under registration. Location service. We can say that okay, the person is just hitting the GPS for that. We will have a tracking service. Right? We'll have a tracking service. Okay. So these are some of the services that we need to make sure are built. Weather and time mapping services, perhaps we can skip that. Right? That is not really a critical requirement. Tracking service for what? So tracking service is going to handle, the traffic service is going to keep track of where the cab rides are. And let us say if a particular person wants to book a cab ride, then it will be able to give us in this particular radius what all different cabs are available. Okay. So location is an entity. Location is an entity. Tracking service is a service. Does that make sense? Does that make sense? Driver verification. We can have all these different services, but let us keep things simple. Right? Let us keep things simple. Let us say that tomorrow we are going to implement the tracking service. We are going to implement parts of the notification service. Right? We are going to implement the ETA strategy, the matching strategy, the pricing strategy. We will skip the payment, we will do the registration, and we will do the OTP service. All right, this is what we are going to do tomorrow. Is that clear? Okay. So once we have these entities and services, now what should we do? Now we should figure out the relationships, exactly, the relationships between these entities. Right, so we had these entities, driver, cab, rider, booking, OTP, rights, this cab type, admin, and payment gateway. Right, so let us look at the relationships of a driver. Let me change the color. Yes, what relationships does a driver have? Yes, a driver has a cab, right? A driver, there's a one-on-one relationship with a cab. Yes, can a driver have multiple cabs? Well, perhaps not, right? Perhaps not. A driver could have multiple cabs, but we would require the driver to register with multiple accounts for multiple cabs, right? We want to keep things simple. We don't want to say that, okay, a driver can switch a different cab. Okay, so we want to say that, okay, for each of, if you have 10 cabs, if you're going to write the 10 cabs, register a different account for each cab. Does that make sense? So, I mean, you could totally have a requirement in which you have multiple cabs for a particular driver. But if you look at a system like Uber, Uber will require you to register with a new account for every single car. Okay. All right. What else? What other relationships will the driver have? So, will a driver have relationship with a rider? Will a driver have relationship with a driver? Well, yes and no. The driver has a relationship with the rider, but it is not a direct relationship. It is not a direct relationship. That relationship goes via a booking. Right? A driver will have a booking, a rider will have a booking, and the relationship between a driver and a rider will be via that booking. Does that make sense? Okay. A driver will have a relationship with booking. Right? Driver will have relationship with booking. What sort of relationship will this be? Can a driver have multiple bookings? Can a driver have multiple bookings? Yes. Can the same booking have multiple drivers? No, right? So the booking only has one driver, but a driver can have multiple bookings. So this is a one-to-many relationship. Does that make sense? All right. Karthik is asking, how can the driver have multiple bookings at the same time? So no, Karthik, the driver will not have multiple bookings at the same time. The driver will have multiple bookings. So these bookings will be in history. The driver will have one current booking. Right? Driver will have one current booking, but he will be related to multiple bookings. Does that make sense? Because you need to store the history of the previous rights. Right? Okay, let us go back then. What about location? Will the driver have a relationship with location? Yes, exactly. So driver will have a relationship with location. So driver has location. Right? Now this is going to be volatile. A driver can have multiple locations, but those locations will keep changing. Do we really need to have the previous locations of the driver? Perhaps not. Right? We just need to keep the latest location of the driver, and perhaps just, 2 seconds or the location 5 seconds ago, right? Just in case the driver has moved. Right? So this has to be a one-on-one relationship. Is that clear? Yes. Okay. Let's look on. So does the driver have a relationship with OTP? No, right? So a booking has a relationship with OTP. A booking will have a particular OTP for starting the booking and for ending the booking. But the driver does not have a direct relationship with OTP. Does that make sense? Similarly, ride status, driver has nothing to do with this. Cab time. Does the driver have anything to do with this? No. The driver is related to the cab. The cab has a cab time. Does that make sense? The driver is related to the cab has a cab time. Admin, the driver really has nothing to do with admin. Payment gateway or receipt? Not really, right? Once again, the booking will have a receipt. The booking will be associated with some sort of a payment strategy. The driver has nothing to do with this. So this is it for the driver. Right? This is it for the driver. Let's move on. Let us talk about cab. What relationships does a cab have? So we already saw that the cab has a one-to-one relationship with the driver. What other relationships will the cab have? So the cab will have a cab type. Cab type. All right. Now, can one cab have multiple cab types? No, right? A single cab will have one single cab type. Can multiple cabs be there that have the same type? Yes. right? There could be 10 Excel cars. There could be 10 sedans, right? So this is a many-to-one relationship. Yes, this is a many-to-one relationship. All right, let's look at what other relationships are there. Does the cab have anything to do with the booking? No. Anything to do with the location? No. Anything to do with OTP? No. Ride status? No. Cab type we've already done. Admin? No. Payment? No. Right. So this is all for the cab. Let's talk about the rider now. Right. Let's talk about the rider. Amit is saying capacity. So Amit, capacity is an attribute of the cab. Okay. Capacity is an attribute of the cab. It is not a relationship with any other entity. Okay. All right. So let us just complete this relationships analysis and then we'll take a break. Great, guys. Let us just complete this first and let us take a break. Okay. Let us now talk about rider. Yes. So what relationships will the rider have? A rider can have booking. Yes. One rider can have multiple bookings. Yes. Can the same booking have multiple riders? Can the same booking have multiple riders? Well, that depends. That depends. Are we talking about a pool booking or are we talking about a normal booking? Yes. So for a pool booking, yes, in case the booking is shared, yes, I can have the same rider can have multiple bookings. Yes. So this is relative over here. Right? We have to decide: are we going to support multiple bookings or not? So for the sake of simplicity, let us say that we are not supporting shared bookings over here. Okay. If we want to do shared bookings, we can totally implement that. But because we have to implement this tomorrow, for the sake of simplicity, let us make sure that we do not really have multiple bookings. Is that clear? Yes. Does that tell me that, okay, I won't have multiple bookings? So is it okay if I create this one-to-many relationship between rider and booking? No, right? Because hey, the requirement could change tomorrow. The requirement could change tomorrow. And if I have such a relationship in my database, it will be really difficult for me to change that database schema later on. Yes or no? It'll be really difficult for me to change the database schema later on. So I should anticipate this requirement. And I should say that, okay, even though I'm not supporting shared bookings now, my database schema will have this rider to booking many-to-many relationship. Okay, so it could be the case that in future I want to support shared bookings. So the booking should be able to have multiple riders. Is that clear? Yes, no? All right. Any relationship between rider and cab? Not really. Rider and booking is already done. Any relationship between rider and location? Yes, the rider will have location, right? So a rider can have location. Okay. One rider can be at multiple locations. Can the same rider be at multiple locations? No, right? The rider has to be at one location. But at one location, there could be multiple riders. Yes, at one location, there could be multiple riders. Okay. Let's move on then. So OTP, does a rider have a relationship with OTP? No, a booking has a relationship with OTP. Right? A rider does not have a direct relationship with OTP. It has an indirect relationship via the ride, via the booking. Okay. Robin is saying that it depends whether the rider is a superhuman or not. Well, even Superman can't be at multiple places at the same time. Okay. Cool. Ride status, nothing to do with the rider. Cab type, nothing to do with the rider. Admin, once again, nothing to do with the rider. Payment, nothing to do with the rider. All right. Is that clear? Will a rider have a relationship with receipt? Will a driver have a relationship with receipt? No. A rider will have a relationship with a booking. A booking will have a receipt. All right. A booking will have a receipt. There's no direct relationship between a rider and a receipt. Okay. Cool. So the rider is done. Rider is very simple. Now let us talk about booking. Booking seems to have a lot of different relationships. Right. So let us talk about booking now. Booking. Okay. So what relationships does booking have? Booking will be related to driver. Yes. Because for a particular booking, you will have a rider and you will have a driver. Well, can a single booking have multiple drivers? Can the single booking have multiple drivers? No, right? One booking will have one driver. And one driver can have multiple bookings, right? We have already seen this relationship. We have already seen this relationship over here, right, in the driver and booking. Yes. But a booking can have multiple riders, right? Just because we want to support shared bookings, right? So we have already seen this relationship as well. A booking can have multiple riders. Okay. What about location? Can one booking have multiple locations? Well, yes and no. Right? It will have a start location and it will have an end location. Right? So basically, this a booking will have one location. It will have one start location and it will have one more end location. Right? So there will be two cases over here. It will be a one-to-one relationship, but there will be two instances of it. Right? There will be two instances of it. Okay. Well, what about the other way around? Can a single location have multiple bookings? Yes, a single location can have multiple bookings. All right. Now, as most of you have started anticipating, what will happen in the case of shared booking? Right? What will happen in the case of shared booking? So, is it just the shared booking case? Is it just the shared booking case? So, normally, when you book a cab, right? Normally, when you book a cab, you can enter multiple destinations, right? And you can reorder those destinations. Yes, destination one, destination two. Yes, you can have multiple stops. So a booking should not have just one start and one end location. It will definitely have a fixed start location. It will definitely have an end location, but actually it just has a sequence of locations. Right? Under the hood, it just has a sequence of locations, and you can reorder those locations. While you're actually in the cab, while you're actually in the ride, you can reorder those locations. Right? So a booking actually has multiple locations. Right? And a location can have multiple bookings. Does that make sense? Yes. So, I mean, once again, this is not part of the requirements. This is nowhere in the requirements. We are anticipating this requirement, right? We are anticipating this change, which is why we are keeping the database schema like this. Okay. What if this changes? Karthik is asking, what if this changes? So, Karthik, this will be able to support all the changes, right? This will be able to support the changes. One to many booking to driver. So, that is very unlikely. Right? It is very unlikely that the same booking will have multiple riders. Right? That is very unlikely to happen. So we can anticipate that. And we can support it. But I mean, I can't really think of a business case in which one of the bookings will have multiple riders. Okay. All right. Please explain a location has multiple bookings. So Radha, once again, the same location, right? Let us say that you are at airport. Let us say that you are at Bangalore airport. Bangalore airport. Right? So Bangalore airport is a location that is in your system. Bangalore airport has a particular, latitude and longitude. It has a particular address. It has a particular city. It has a particular average traffic load. So at the same location, you can have multiple bookings. Does that make sense? Yes. Perfect. All right. So what other things does booking have? So does booking have anything to do with an OTP? Does booking have anything to do with an OTP? Well, yes, the booking has an OTP. So the booking has OTP. Right? How many OTPs does the booking have? Is it a one-to-one? Okay, first of all, can one OTP belong to multiple bookings? Can one OTP belong to multiple bookings? No. Right? So one OTP can belong to only one booking. Well, can one booking have multiple OTPs? Yes, right? So it could be the case that the booking has multiple riders. Yes, the booking could have multiple riders, and in this case, you will have different OTPs for each of those drivers. Yes, right? So one booking can have multiple OTPs. The OTP doesn't really expire. In this case, the OTP doesn't really expire. Right? Okay. Now let us move on. So, does booking have anything to do with ride status? Yes, right. This is basically the booking status. So this booking will have a relationship with the ride status. Okay. What sort of relationship is this? This is a one-to-many relationship. Is it? Or is this a many-to-one relationship? It is a many-to-one relationship. Okay? It is a many-to-one relationship. One booking will have one status, right? And the same status can be with multiple bookings, right? There could be 10 bookings that are in the waiting status. There could be 10 bookings that are in the completed status. But one booking at any point could only be in one status, status. Okay. So Ashish is saying that you forgot cap. So once again, Ashish, the booking does not have a relationship with the cab. The booking has a relationship with the driver. The driver has a relationship with the cab. All right? Is that clear? Cool. Let us move on then. People are asking why is, okay, so that's a good question. So the question over here is, why is a booking related to a driver and not a cab? Are you booking a driver or are you booking a cab? So that's a good question to answer, right? When you go to Uber, what are you really booking? Are you booking a driver or are you booking a cab? Or are you booking them both at the same time? You're actually booking them both at the same time. Yes. But let us try to find out which one of these is the actor. Can a cab act on its own? Can a cab act on its own? No, it can exist on its own. It can. So basically, every cab needs a driver. Every driver needs a cab. But a cab is not really an actor. A driver is an actor, right? So it makes more sense to associate a booking with a driver. Does that make sense? Now Rahul says, what about self-driving cars? Right? What about self-driving cars? So if we are anticipating the need for self-driving cars in the future, then yes, we should be able to support that as well. Right? Then we should be able to support that as well. For now, let us, for the sake of simplicity, let's skip that. All right. Is that clear? Let us say that we have a location like India. So in India, in the next 10 years, you will not see self-driving cars because the roads are so bad. So, all right. Cool. Let us move on then. So what about a booking? What about a booking and an admin? Does a booking have anything to do with an admin? No. The booking has something to do with the payment though. Right? The booking has something to do with the payment though. So the booking will have a payment receipt. Payment receipt. Yes. One booking will have one payment receipt. Or it can have multiple payment receipts because there could be multiple riders. Yes. One booking can have multiple payment receipts. One payment receipt will only be for one booking. Yes, one payment receipt will only be for one booking. Does that make sense? Well, what about the payment strategy or the payment gateway? Should a booking have something to do with the payment gateway? No. Right? The payment receipt has something to do with the payment gateway. The payment receipt, this will specify, okay, what the payment gateway was. The booking doesn't really care how you make the payment. As long as you have made the payment, the booking doesn't care. The payment receipt will reflect, okay, what was the mode of payment. Does that make sense? Yes or no? Kunal is saying, I do not understand how OTP is same across multiple riders in case of Uber sharing. No. So OTP is not same. So if we look at the booking and OTP, we have a one-to-many relationship. The same booking can have multiple OTPs. So for every rider of that booking, if it is a shared booking, every rider will get a different OTP, right? Which is why one booking will have multiple OTPs. The one OTP can only belong to one booking. Okay, one OTP can only belong to one booking. VV Singh is saying, is booking looked from the perspective of riders or cab? So the booking is a separate entity. We are neither looking at booking from the perspective of rider, nor are we looking at from the perspective of driver. Right? A booking is separate. A booking basically is the relationship between the driver and the rider. Okay, so booking is a separate relationship, separate entity completely. Okay, Rishi is saying, how does a booking have multiple invoices, payment receipts? Well, a booking can have multiple riders. Right, a booking can have multiple riders, which is why the booking has multiple receipts. Okay. Now there's one thing over here. There's one thing over here that we are missing, and that is very critical. That is very critical. There is something over here that is a bad design. There is something over here that is a bad design. Basically, if we have a booking, right? If let's talk about a shared ride. Let's talk about a shared ride. Shared ride. Right? In this shared ride, should we say that okay, there is a person A, there is a person B, they made the same booking, right? They have made a booking. Yes. Should both the people have the same booking? Should both the people have the same booking? You should generate separate bookings for them, right? What if one person cancels? What if one person cancels? Okay. But both of them are going to share the same ride. Yes, both of them are going to share the same right. So what we need to do here is we need to make a distinction between a booking and a trip. Does that make sense? We need to make a distinction between a booking and a trip. So over here, we will have to change things a little. So a booking will have driver. So we are renaming this booking to trip. Okay, a trip will have a driver. Okay, a trip will have multiple riders. All right, a trip will have multiple locations. A trip will have multiple OTPs, or actually not a trip. A booking will have OTP. A booking will have one OTP. Yes, a trip will have status, or a booking will have status. Right? A trip will also have status. A trip will also have status. Okay, this will be a many-to-one relationship. Then there will be a one relationship between a trip and a booking. Right? One trip can have multiple bookings. Does that make sense? One trip can have multiple bookings, and the customer, the rider, is related to a booking. The booking is related to the trip, and the trip is also related to the driver. Right? So this is what the relationship is like. Does that make sense? Yes. Shubham is asking, one can have multiple entities and multiple relationships, but how to concise this while giving this in an interview? So Shubham, when we actually dive in the code tomorrow, we will see, we are currently taking an 8-hour class, right? So the purpose of this is not to just focus on the interview. The purpose of this entire exercise is to understand what low-level design is and how to approach a problem. Right? For approaching a problem from the interview perspective, you will have to make some changes. Perhaps we can talk about that some other time. Okay? All right. Trip rider relationship is wrong in the sheet. So let us quickly see the trip and rider. No, so one trip can have multiple riders. One trip can have multiple riders because a trip could be shared. Right? Similarly, one rider can have multiple trips because you're not going to make just one booking, right? Does that make sense? Now over here we have this change over here. One rider, one rider can have multiple bookings, but one booking can only belong to one rider. Right? One booking can only belong to one rider. And how will we handle shared bookings? How will we handle shared trips? We will say that a shared trip has multiple riders via multiple bookings. Does that make sense? Yes. One to many to rider. So basically, a rider can have multiple bookings, right? A rider, I can book a ride for today. I can book a ride for tomorrow. I can book a ride for 1 year later, right? I could have booked a ride yesterday. So a rider can have multiple bookings. Is that clear? Okay, so this is all that we have basically in this. Now what we have done is we have figured out the requirements for a problem. We have broken the problem down into executable things. Right? We have figured out what the services are going to be. We have figured out what the entities are going to be. We have figured out what the relationships are going to be. Now what we have to do is, we have to, after the break, we will cover the following things. We will cover some of the design patterns. So patterns like the strategy pattern, right? We will be using this in tomorrow's hands-on coding. So we need to study this, right? This is what we'll be covering. We will be covering the database design, database schema design. So currently we have the entities and relationships figured out, but how do these really map to the database tables? Okay, how do these really map to the database tables? That is something that we have to look at. Does that make sense? Right? Where do the attributes go? What do we do with the entities? What about the relationships? Yes, we have to think of all of this. So we will quickly talk about that, right? And finally, we will end this with some things about how to normalize the database and some tips of what the Scalar Academy is going to be. All right. Komal is asking, will we be using NoSQL? No, Komal, we will not be using NoSQL. Right. The correct database to use over here will be a SQL database, and we'll discuss why. Okay. Perfect. Now this is the much anticipated part, the break. So let us quickly take a break now. It is 4:05 in my clock. Let us say that we will be back by 4:35. 4:35. Okay. So please make sure that you stand up from your desk, you do some stretching, you have some food, right? You drink some water. Don't just sit over there. Don't just sit on the couch. All right. Please move around a little, and then we'll be back by 4:35. Okay. 30 minutes is too long. Well, Mayank, a lot of people want to have food, I'm guessing, and 30 minutes will go by very quickly. Okay, so don't really worry about that. 30 minutes will go by very quickly. Can you zoom out? Definitely. So this is what we have. Hope to finish on time. Yes. So we will end by 6 p.m. We will end by 6 p.m. All right. What will we cover tomorrow? We will do the hands-on coding tomorrow. Okay, we will do the hands-on coding tomorrow. Right? Perfect. Let's go on a break. Let us be back by 4:35 p.m. All right, let us be back by 4:35 p.m. I will be back a little early. So I will try to be back by, let's say, 4:20. And if we have any questions, I will try to answer those questions from 4:20 to 4:35. Okay? Perfect. All right, then let's go on a break. Can you please share this document? So after this class is done, I will be sharing this document. Okay, so I'll be sharing these notes after this class is done. And tomorrow as well, we will be sharing the code. Do we get this recording? Unfortunately, no, Shiva. You will not be getting the recording. You will be getting the notes and the code. Yes, of course. We will be sharing the resources as well. So if you want to learn more about low-level design, we will be sharing plenty of resources with you. Okay? Cool. Perfect. Let's go on the break then. See you guys in half an hour. Okay? Yes, yes. This same meeting will continue. You don't have to rejoin another link. This same meeting will continue. Okay? So I'm just going to turn off my mic. I'm just going to turn off my camera, and we are going to stay here. All right? Good. All right, so we are not back yet. The break is still continuing. We will resume the class at 4:35. But in the meanwhile, if we have any questions, right, for the next 15 minutes, we can take that. All right. Are we going to do hands-on using Java? Yes, we are going to do hands-on using Java and Spring Framework, but that will not be today. That will be tomorrow. Okay, so tomorrow, once again, we have a class from 2 to 6 p.m. Right, so 4 hours over there, and we'll be doing the hands-on coding then. Can you please define relationship between trip and booking? Definitely. So once again, we have this thing. Right? So let us try to think of this one more time. Right? We want to allow shared rights. Right? We want to allow shared rights. Now, if we say that a rider has booking, right? A rider has a booking, and this booking can have multiple riders. That is not okay. You can't see the screen. Just a second, guys. Okay. Sorry about that. Let me share the screen once again. Yes. Can you see the screen now? Yes. Just give me a second. Perfect. All right. So once again, let us try to think about the shared right thing. Right. So we have a rider, we have a booking. Right. Now, if we say that if the same booking can have multiple riders, then things get complicated. How do things get complicated? Let's look at that. So we said that a booking can have a status, right? A status like in progress or cancelled or waiting for something, and so on and so forth. Yes, or basically ride arrived, or basically completed, and so on and so forth. Okay, let us talk about the shared ride thing for us. So suppose I have this rider one. This rider one wants to go from A to C, right? There's this rider two. This rider two wants to go from B to D. Yes, and they have booked a shared ride. Now, when will I set the booking status to arrived? When will I set the booking status to arrived? The arrived status is different for different riders, right? For this rider, the cab has arrived when it has reached point A. For this rider, the cab has arrived when it has reached point B. Okay, so I can't have multiple riders in the same booking. Does that make sense? Yes. Okay, so what I'm going to say is a rider is connected to a booking, right? Each booking can only have one rider. But in turn, the connecting entity is a trip. A trip can have multiple bookings. Booking 1, booking 2. This booking can be connected to rider 1. This booking can be connected to rider 2. This booking can be connected to rider 3. So these three people are sharing the trip. Does that make sense? So the relationship between a trip and booking is that one trip can have multiple bookings. One booking will always belong to one trip. Okay, in the same booking, you can't take different trips. So booking is a subset of trip, kind of. Because we wanted to support sharing things, then we figured out that, okay, it is a better idea to break this down, booking and trip into separate entities. Right? When does a trip start and end? So a trip does not really have a start and end, right? A trip can be continuous, right? So it doesn't really matter for a trip to have a start and end because think of something like this, right? So there's this cab that started at point A. From point B to point D, it got a shared booking, right? Then from point D onwards to point E, it got another shared booking. So there was this rider who went from point B to point E. There was the rider who went from point B to point D, and there was another rider who went from point D to point E. Right? So it need not be the case that this trip has a definite end. It need not be the case that the trip has a definite end. Does that make sense? The trip will have a start and an end, but it will not be pre-decided. The trip will have a start and an end, but it will not be pre-decided. It will change. It will keep on changing as new bookings are added to the trip. Okay? Is there a direct relationship between the rider and a trip? No. Ashana, once again, the relationship between a rider and a booking exists. Right? A rider is related to a booking. A rider can have multiple bookings. A booking will only have one rider, and one booking will only have one trip. Is it clear? Shouldn't we have end-to-one relationship between driver and location, just like we have end-to-run for rider and location? We do have that for driver and location as well, right? Let us quickly see that. Okay, so we wrote one-to-one. This will be many-to-one. My bad. This will be many-to-one. Right? The same location, we can have multiple drivers. Thank you for that. Okay. Why do we need trip at all? Booking should be sufficient, right? So Neha, once again, the reason we need trip is because a booking can have multiple statuses, right? Each rider will see the booking in a slightly different manner. Right? The pricing for each person will be different. The payment, the total cost for each person will be different. The status for each person will be different. If you have cancelled, right? Let us say that me and you are going in a shared cab trip. Now, if you cancel your trip, that does not mean that my trip also has to be cancelled. Does that make sense? So the trip is the same, but the bookings are different. Your booking is different and my booking is different. Nitin is asking how nearby entities are fetched, what DB would be considered for that. So Nitin, that will come tomorrow. Okay, we will discuss what algorithms we can come up with and what sort of architecture we can come up with to make sure that, nearby entities, so nearby cab rides are still fetched in an effective manner. Okay. Dell is asking, is booking for the driver and trip for the customer? No. So trip is basically a secondary. Trip is not there for the trip is basically, you can say that a trip will have a ride. Trip will have a driver. Okay. And a trip will have bookings. And a booking will have a rider. Okay, you can think of it in this way. Okay. How do we choose programming language framework? Well, your choice of programming language and framework is usually based on your personal interests, right? So first of all, we need to understand what sort of programming language are we looking for, right? You can write this entire code in SQL, right? SQL is Turing complete. You can write this entire code in assembly. You can write this entire code in COBOL, right? But I understand that you will not try to write this program in either of these languages. Right, so the first thing that you need to decide is that, okay, I'm going to use a programming language, a high-level programming language, and I'm perhaps going to use a web service framework on top of that, right? So once you have decided that, now you can choose your technologies any way you want. So you can use Python plus Django, or you can use Python plus Flask, or you can use Rust plus Rocket, or you can use something like Ruby plus Rails, or you can use Java plus Spring, right? And so on and so forth. You will use PHP and Laravel, and so on and so forth. All right. So this is just your personal choice. This is just your personal choice. At any moment, a rider will have one booking, right? Yes, Ishan. At any given moment, a rider will have one booking that is currently in progress, right? That is currently in progress. It could be the case that the rider has one booking currently and two bookings are scheduled for the future. Right? That could totally happen. Also, the rider will have multiple bookings in the past. Now, we need to save all those things. Right? When we are describing these relationships, we are not saying what does the current scenario look like? What is the current active booking? Right? We are saying what are all the bookings that are related to this rider. Right? And that will incorporate all the past bookings, all the current bookings, and all the future bookings as well. Is that clear, Ishan? All right. Are we going to build complete application like code, DB, and going to deploy in the cloud? Yes, Sri. So, Sri Krishna, yes, we are going to do that. We are going to set up the database. We are going to write the code, and we are going to deploy it to Hero. Right now, there will be pieces of the code that I won't write. Basically, I will give you some of the main concepts of the code. So we will write some of the entities and some of the classes together. But apart from that, I will be copy pasting a lot of code from my reference code. Okay, so last time we had this masterclass, we were not able to complete the code in time just because we had a lot of tasks to do. Right, so this time around, I'm going to copy paste a lot of code. I'm going to make sure that I explain each and everything. All right, but yes, we will be setting up the development environment. We'll be creating the database from scratch, and we'll be basically starting the project from scratch, and we'll be deploying it. Is solid principle part of low-level design, and will we discuss it in this masterclass? So yes, solid principle is part of low-level design, and unfortunately, no, we will not have time to discuss it in this masterclass. Okay, So solid principle is a very important part of low level design. We will be deploying the code. We will deploy the code to Heroku. Okay. How we decide between SQL and NoSQL database? Sort of, we will come to that. So just after this break is over, we will start with that. VV Singh is saying existence of trip entity is not very clear, even for shared rights. That's fair enough, VV Singh. So let's do one thing. Just try to go over this once again. Just try to go over the notes after the class once again. And in tomorrow's class, when we actually do the live coding for this, things will become much more clear. Because in code, we will have the clarity of what we are exactly doing. Okay, so things will become much more clear tomorrow. Why exactly this trip is needed, why exactly bookings are needed. Pulkit is saying how to get cab details for a particular booking if driver changed the cab, as we don't have booking and cab relation. So Pulkit, what we are doing over here is we are enforcing this thing. We are enforcing a constraint that if let's say that Pragya drives cab, right? Pragya drives Uber, right? And let's say Pragya has one car of his own, right? And Pragya has rented two cars, right? Pragya has rented two cars. Now, what Uber enforces is that Pragya should register an account for each of these cars separately. Okay, a person or driver should register an account for each of these cabs separately. Does that make sense? So one driver is only associated with one car and vice versa. So this is Pragya 1. I will have another account Pragya 2. I will have another account Pragya 2 that using which I will use my other car. All right. How to distinguish between attribute and relationship? So that's a very good question, Sudhanshu. So usually attributes are properties. Attributes are properties of a particular entity. Attributes themselves are not entities. Right? Attributes themselves are not entities. So let us talk about an attribute like a name. A name will be a string. Right? Let us talk about something like an age. An age will be an integer. Right? Whereas something like a status, this thing is itself an entity. Right? This thing itself is an entity. So relationships are between two entities. You can't have a relationship of an entity with an attribute. Right? A relationship owns an attribute. An entity owns an attribute. An entity has an attribute. An entity has relationships with other entities. Okay. In other words, what makes that one thing should be a separate entity and not the attribute of one thing? That's a very good question again. So, Sudhanshu, that really depends on a lot of things. So, I'm not really sure how to put that over here. Mostly that is based on your understanding of the problem. Right? Mostly that is based on your understanding of the problem. So basically, try to think of it this way. Attributes in general don't have behavior. Right? Don't have behavior. Whereas entities do have behavior. Do have behavior. All right. Additionally, attributes are stored as columns in our database, whereas entities are separate tables. Separate tables. So when we talk about this database design, we will come to that right after the break, and we will discuss that. Okay. Rijesh is asking, I have a doubt. Is it a good idea to use APIs for frequent requests like location update to database, or is there any better ways of doing that? So Rijesh, for something like Uber, you can totally go ahead with some basically an API that you constantly have to ping to update the database. So basically Uber is not that high throughput. So if you're designing something like games, right? Let us say that you are designing PUBG. Now in PUBG, you cannot say that, okay, I have 100 players on my server, right? Each of these players is going to send me a request every, let's say, 0.1 second. That is not feasible because the latency and things, the overhead of creating the connection, dropping the connection will be too high, right? And for these cases, you use something else. So you will use some sort of a persistent connection. Something like a WebSocket, right? So for high throughput games, for something like PUBG, you will use a WebSocket connection, right? Are we going to discuss API design as well? So Shubodh, we are going to work on the API tomorrow. We are going to actually code it. And during that, we will briefly discuss about what REST APIs are, why they are needed, and basically what benefits REST APIs have. Okay, and we'll be creating our code in terms of using REST APIs. Is there any use case where dependency injection is not the ideal way? Well, dependency injection is usually very useful when you're trying to test the code, right? So if your code is expected to be very complex, then you would go ahead with dependency injection. If you're, I mean, it's usually a thing that you do with large scale projects, right? I'm not really sure if there is any use case in which the project is sufficiently complex, but dependency injection is still a bad idea. I'll have to think about that, frankly. Okay, Nikita? So from what I'm aware, I mean, dependency injection, you would try to use that whenever you have a large project. What is the HLD for this requirement looking like? Just a narrative. So Prakash, HLD cannot be, I mean, cannot discuss just the HLD in a very short manner. Uber will have a lot of different services in the architecture, right? So we will have to talk about a lot of things because we will have to talk about the authentication, the caching, the location service, how that is stored, how that is scaled, right? What the load balancer looks like. We'll have to talk about a lot of different things, right? So HLD is a completely separate discussion. All right. Please share this note by today itself. Yes, Amar, we will be sharing this note today itself. Okay. Ooh, we have a lot of messages. All right. Do we have lectures for HLD? So we are not going to discuss HLD in the masterclass today, but in our curriculum, we cover HLD. Okay, in our curriculum, we cover HLD. Okay. Okay. So let us take a pause over here and let us try to think of, I mean, why are we studying these things? Or basically, what makes a person successful, right? So let me rephrase this as a different question, perhaps. How many of you over here are studying at IITs? How many of you are here studying at IITs? Can I see just a show of hands in the chat? In the chat. Yes, okay. So we have around 900 people here, and out of that, I saw like 20 hands being raised. Okay, so around 20 out of 900. How many of you are studying at MIT or something like Stanford? I mean, not currently studying. I mean, if your alma mater is IIT, right? If you have studied at IIT at some point, then that was the question, right? Has any of you studied at MIT or Stanford? Why is this question coming in the first place? We'll come to that. We'll come to that. So I'm guessing probably no one of you, right? Was in single digits, 0 by 900 perhaps. Right? How many of you want to study at MIT or Stanford or IIT? Yes? I'm guessing pretty close to 900 by 900. Yes. Okay, I see a ton of hands over here. Yes. Now, what is it that these colleges do? What is it that these colleges do that a third tier Indian college does not really do? What is the difference between these colleges and other colleges? Why are these colleges successful? Why are the students at these colleges successful? So let us lay down some of the things. So basically, it could be because of curriculum. So do IITs, MIT have better curriculum? It could be because of better teachers. All right. It could be perhaps because they are smarter. Right? So people at MIT are smarter. All right. What else could it be? It could be based on the money. So they have a lot of money to give their students. It could be basically money and infrastructure. All right. What other things? The research. Okay. High admission criteria. Okay. Admission criteria. All right. Peer group, or basically the environment. Okay, now let us quickly talk about all these things and let us see which is really important. Okay, let's talk about the curriculum. So curriculum doesn't really matter a lot. Curriculum is important, but almost all the colleges have the same curriculum. So even if you see MIT develops a curriculum, the IITs will copy it. Right? IITs blatantly copy the curriculum of foreign schools. Right? Third tier colleges in India, so colleges like UPT colleges, they copy the IIT curriculum. Right? So even third tier colleges in India, they have more or less the same curriculum as MIT. Does that make sense? They use the same book. Both MIT and third tier colleges, they use CLRS. Right? They use the same book, S. Sudarshan's book for DBMS. Right? So the curriculum over here is same. So curriculum is important. I agree, curriculum is important. but it is not the most important point over there. What else is? Teachers. Well, once again, teachers are very important. Well, at places like MIT, right? At places like MIT, you even have Nobel laureates, right? You even have Nobel laureates as teachers. Now, teachers are very important, but any college who is paying well enough for a particular teacher will get good teachers, right? So IITs have great teachers; they have some of the best teachers in the world. MITs have great teachers. Now, some third-tier colleges, they don't have good teachers because they don't pay their teachers well enough, right? So teachers is definitely an important part, but it is still not the most important part. Okay, it is still not the most important part. But they are smarter. How many of you think this is the case? Yes. Well, this is not the case. I'm here to tell you, smartness is kind of a myth. It is more about practice and hard work. Right? If you are thinking that some other person is smarter than you, then you are dead wrong. Right? It is just that that person has trained more than you. That person has practiced more than you. Smartness, I mean, God gift things, they don't exist. All right. A hardworking person will always beat a genius. All right. That is one thing that I have learned the hard way. So smartness doesn't really matter. There's nothing like intelligence. Almost everyone in the world has the same level of intelligence. Okay. Money and infrastructure. Well, yes, these matter. Infrastructure and money, these matter. But we are computer people, right? We are computer people. We don't need a particle accelerator in a lab, right? We don't need we don't need a high cost setup to do both science and condensation, right? We just need to have a laptop. So infrastructure is probably not the right thing over here. Right? At least for computer scientists, we can't blame it on the infrastructure. Right? Research. Well, research is not the cause. Research is the output. If the rest of the things are in place, then research will be the output. Good research will be the output. Right? So research is basically not the cause. It is not the cause. It is an outcome. All right. Okay. Admission criteria. Well, IITs have the toughest admission criteria across the world. That is true. But even something like UPTU, right? Even something like UPTU that has more number of applicants than a place like MIT. Right. So if you just look at the acceptance numbers, then UPTU, a third tier college like UPTU, will have a lower acceptance number than MIT. All right. Okay. So the final thing that remains is the peer group, right? The peer group, and this is exactly what affects the most. So what you might have noticed is that people who go to colleges, it is not the case that only smart people go to these colleges. It is not true. But whoever goes to these colleges, that person becomes smart. And the reason is that if you see everyone over there working hard, working very diligently towards a particular goal, you yourself will be inspired to do that. Does that make sense? Yes. So basically, I have studied from both a third tier college and a first tier college. So I was studying at MIT. Right? This is a college affiliated with UPT. I did my bachelor's from here. Right? Apart from that, I also studied at IIT Bombay. Right? I did my master's from here. Now, we had assignments. We had assignments here as well. Over here, the assignments, nobody really did them. Right? Nobody really did the assignments. If someone did the assignment, one person did the assignment, everyone else copied this. When I was at IIT Bombay, assignments really mattered. Students competed, right? I was even competing with my roommate to see whose assignment is better. Right? There's a lot of competition over there, and that competition is constructive. It is not that I'm saying, I will destroy your computer so that you can't submit the assignment. That competition is constructive. We are helping each other out. We are upskilling each other. All right. So one of the things that you have to remember is that your peer group matters the most. All right. Is that clear? Yes. Now this is not just true for education. This is also true for work. It is not the case that only smart people go to Google. However, it is the case that once you have gone to Google, you will become smart. Does that make sense? This is also about your work culture. So even if you are employed, even if you are currently working, don't think that this does not really make sense for you. All right. Perfect. So that was enough of Gyan. Let us move on then. Okay. Let us move on to some of the design patterns. Right. So as we said, we have a lot of design patterns, but some of the design patterns we will actually be using in the code tomorrow. Okay. So let us first of all talk about one such pattern, which is the strategy pattern. All right. What's this pattern? This is the strategy pattern. Now, what does the strategy pattern really talk about? Okay. What does the strategy pattern really talk about? So let us talk about this from an example. Okay, so let us say that we have something like the payment strategy, or let us say that we have something like the pricing strategy. pricing strategy. Right. Now, have you noticed in Uber, as soon as it starts raining, the prices go up? Yes, this happens. Yes. If there's a lot of traffic, a surge pricing gets employed. Yes. At night time, the pricing is higher. Yes. Apart from that, what other things does the pricing depend on? The pricing depends on availability of the cabs, right? So basically demand and supply. It depends on the cab type, the kind of ride you're booking, right? What distance are you covering? Yes or no? Yes. Fuel cost is not really counted in the pricing strategy, right? The duration. So how much time is the driver waiting for you, or how much time does the